Yeah, that's a really interesting question. So in the last 5 years or so, there's been this renewed interest in perfusion relative to fed batch. So we're finding, with these higher, tighter processes that we're able to run in perfusion mode where there's basically continually media being added to the bioreactor and harvest pulled out, where we're getting much higher titers out of these types of processes. And what that helps do is drive down the overall footprint of the manufacturing facility. So now you can use maybe a 100, 200, 500 liter bioreactor to produce the same amount of material that it might have taken you, a 10,000 liter bioreactor to produce within a fed batch process. So that's the one big benefit, is you're driving down the bioreactor size. So that's obviously going to reduce capital costs, etc. Be more easily to expand outwards. So run multiple perfusion bioreactors versus multiple these very large 10,000 plus liter bioreactor processes. Perfusion also has some interesting other advantages, such as typically higher consistency within the product being delivered. It's running under a steady state condition, as opposed to fed batch processes, which can be a little more dynamic. So those are some of the benefits, and et cetera. Yeah, so to some extent, the decisions made to either go with fed batch or a perfusion process really can, one, have to do with the molecule being manufactured. So there's, for labile molecules that are unstable, that may really indicate a pretty clear line towards perfusion. Also, what the demand is for the molecule may impact some of those decisions, or where you're looking to manufacture it. You may find that, perfusion would be more beneficial if you need to have multiple different manufacturing sites and you want to keep them smaller to generate in-country, for-country material, whereas other products may be more suitable to fed batch culture. So it's really looking at a molecule by molecule basis, understanding not only the product, the properties of the molecule, but also the overall demand for the product. Yeah, that's a good question. So I think it all comes down to process design with these perfusion processes, particularly with respect to downstream. So perfusion has this advantage that you can oftentimes freeze process intermediates and right-size your downstream based on essentially how much product you want to push through into a single batch. So in a lot of cases, perfusion may in fact offer more flexibility with respect to downstream process sizing as opposed to fed batch. That's a good question. So the first thing that we find is we really got to target higher capacities on our downstream processes. So that's essentially looking at next generation resins with higher loading capacities, etc. It's going to reduce the number of cycles that we're running during the downstream, reduce buffer volumes, etc. So that's probably the easiest way to go about doing that. The other is using newer technologies such as membrane chromatography, etc. Those can be run at much higher flow rates. It's obviously going to bump your productivity and reduce your processing time. Finally, there's new innovative technologies companies are using, such as continuous processing. This is based off simulated moving bed technologies, etc. Those are sort of on the forefront of the improvements, whereas the other technologies that I've discussed have sort of been adapted more readily in existing processes. Yeah, that's a great question. So as a CMO, that's really what we're experts at, is scaling up processes and getting our customers GMP materials. So the way we typically go about doing this is we'll bring a customer's process into our development labs and really understand how to execute their process using our scaled down models. And since we own these scaled down models, we've used them for multiple different clients, different cell lines, different types of molecules, we understand really well how to take those processes and get them into our GMP facility so they scale up right first time.